Hey everybody, welcome in here. We got an interesting video today. We're going to use Desmos to do a linear regression. Now typically for my linear regressions, I tend to use Google Sheets or Excel, but I finally figured out how to do this in Desmos, and it's a pretty good method. I'm excited about it for a variety of reasons here. Primarily that you can work really well with the residual. So let's check it out here. Let's go to desmos.com/calculator. And you can see it right here. And now I'm going to change the screen size really quick just to make it easier to see on the video. And you know what? While I'm here, I clicked on this wrench. Let's go ahead and add a label for our problem. I believe the x-axis in this particular problem is pizza toppings, and the y-axis is price, and we are trying to determine how much we might charge or expect to pay for, you know, an average 3-topping pizza or 4-topping pizza or whatever it might be. So here we go. Okay, we got prices, we got pizza toppings, good. Now we're going to come up here to the 1 and we're going to input our data table. Now I first just tried typing this in and it didn't work, and what you need to do is click on this plus sign in the upper left hand corner, and you're going to insert a table right here. Okay, now I'm going to type in my data table, which is 1 and 10.5 and 3-topping pizza for $9. That's a value right there. 4 toppings for $14. This is a different restaurant, obviously. 6 toppings for $15. 3 toppings for $12.50. 5 toppings for $16.50. And 0 toppings, so just a plain cheese pizza for $8, and then a 2-topping pizza for $9. So here we go. We got our data table put in there, and it's in green, my favorite color, but it's not actually showing up on the screen. So at first I was like, oh, is Desmos wrong? What's going on? Is this broken? And I just realized maybe I just need to zoom out a little bit, so you can zoom in, zoom out there. You can also, you know, pinch on your device, whatever it is, and click and zoom around. All right, there we go. Now we can really see the data, and you can see our label there, the number of pizza toppings, and the prices. So we're going to add our best fit, and we're going to do it 2 ways. First, we're going to do it manually just to practice, you know, seeing what is the line of best fit. Then we're going to let Desmos go ahead and put that in for us so that it will be with, you know, the computerized formulaic precision. Here we go. First thing first, we're going to say y equals mx plus b. And we'll go ahead and add these sliders for y, not y, for m and for b. And you can see right here, right now, m and b are set to 1. Let's see. If we're going to change this, let's see. First thing I do normally when I'm placing a line of best fit is try to approximate the slope, which that looks like the approximate slope of the line of best fit. Then I move it up so it's in the right area right there, and it looks a little too steep to me somehow, so I'm gonna back it down just a little bit and then increase that. Let's try that right there. That looks like a pretty good line of best fit. I'm sure it's not perfect, but you get the idea, right? So now we're going to I'm going to save that as my guess of the line of best fit. What I'm going to do is I'm going to change out those variables right there, or the m and the b. I'm going to put the actual numbers in here that I'm guessing, and then I'm going to delete the sliders, and I will show you why I'm doing that in just a second. Okay, so there's my guess. That's the black line. Now in a different color, I'm going to go ahead and put in the actual computed line of best fit here. So in order to do that, we're going to type in y1, and you can see here that it's recognizing, oh, y1 is now this 8-element list, right? So it's pulling the data into its y1. Now, instead of typing equals, we're going to say approximately, because of course we're estimating the line of best fit. So we're going to say m, and then we're going to say x1. And again, that's pulling here from the x column of our data table here, the number of toppings. plus B. And there you go. You can see the green line. And let's zoom a little bit here. You can see the green line is the actual Desmos computed line of best fit. And the black line is my guess as to what that was. So if you want to just skip doing your own guess, that's fine. Okay, so here we go. We can turn that off or on. You know, you can see, all right, my guess was a little too steep and the y-intercept was pretty good. Let's see the actual numbers here. So it was 1.35 instead of a 1.5 for the slope. I guess 1.4 if you, 3.6 if you round it, and then 7.7 for the y-intercept. So that makes sense. And you can see the r squared and the r values there. And then something I really want to do here is plot the residuals. So let's go ahead and click on this residual plot right here. And you can see those pop up here in purple. And not only do they pop up on the graph, but they pop up in the table as well. So you can see here, you know, what's a cheap pizza, right? Like a negative residual here would indicate a pizza that's cheaper than normal. It's below the line, right? So like the 3 toppings for $9, that's a good deal. An expensive pizza would be like, you know, paying $16.50 for a 5-topping pizza, right? So you can kind of get a sense of, you know, which one of these is more expensive or not. And you can look at your residual table down here, which can give you some information about whether a line of best fit is the right option for the data, which in this case it does appear to be. So anyways, there we go. I think we have fulfilled the mission of this video. I'm going to go ahead and end it. You guys enjoy and good luck.